set. Your mic on too?
Test.
OK. Great. Let's get started. OK, welcome, everybody. My name is Matt Mason. I'm here with
Tessa Palmer.
And today we're here to talk about Power Query and the Power Query formula language.
So quick peek at the agenda. We're going to start with an overview of Power Query, why you would even use Power Query and this Power Query formula language. And then we're going to do an introduction right into the language. So we're going to talk about types, values, functions, and we're going to spend a lot of time on examples. So real-world examples where you're actually going to use this formula language to do a little bit more than what you can do just through the UI.
Yeah, and so underneath Power Query, there's a whole formula language, which is what we're focusing on today. And things to keep in mind is that we don't expect you to actually learn the whole language within this 1-hour session or 75-minute session. So we're basically going to point you in the right direction. It's just recently that I had to learn the whole language. So I'm going to point out some of the things that helped me learn. And like we said, we'll post all the samples and examples afterwards. You guys can sort of follow along. The goal is to give you enough background on the language itself to make you dangerous. So quickly about Power Query itself, where it fits in. So we say it's part of the Power BI solution. It runs in Excel. I always say it's the starting point of the Power BI stack. It's the way to get data into the rest of your Power BI solutions. So Power Query is grabbing the data in. Power Pivot is building your models on top. You have Power View to visualize the data, and then Power Map to also visualize geospatial data, make movies, and things like that. OK, so quickly, we'll switch over to Power Query, and I'll call out some of the key components you need to be aware of when you are wanting to use M. So Power Query has its own tab. Hopefully you guys, actually, so quick show of hands. Who here was in the session yesterday? Faisal and Miguel's session yesterday afternoon?
Great.
Great, OK. Who here has never seen Power Query before? Anybody? So a couple of people? Yeah, OK, so this is a 400-level session. Very brave of you to go to a 400-level session of a product you haven't seen. But hopefully it will be OK. So yeah, we have Power Query. It's a tab. It can connect to different data sources, a variety of different data sources here. You'll find that when you are using the M language, the Power Query formula language, you'll do a mix of using the UI and also writing actual code. OK, so here I can connect to a SQL Server database. I'll type in localhost. One thing I want to call out on this dialog right here, so here I'm connecting, and there's this SQL statement here. And we'll talk about this a bit more a bit later. We call this feature native database queries. So Power Query actually lets you type in a SQL statement rather than using Power Query to build up the query. You can type in the SQL statement, and it just gets run directly. We'll tell you exactly why you shouldn't use this feature. It's not that it's useful in some scenarios, but as you see, as you're writing code, it's very limiting once you start using it. So keep that in mind. OK, so I can connect to a SQL Server database. It's going to show me my local SQL server, and let me just connect to one of these. And so I have some data here. Maybe I'll remove a column, right? I can do some reordering, maybe remove some more stuff. I don't want this either. Great. And so as I do these transformations in Power Query, I did all those different steps. We log all those steps here, right? You can actually see all the different applied steps that I just performed through the UI. And I can actually drill back through each step, and it changes. I can see the code as it goes from step to step and the different transformations that I'm actually doing. Each step has a formula behind it. Okay? This is the formula behind the step. You see it's actually very similar to Excel formulas. Okay? It's basically a function invocation that defines what the step is going to be done. By default, that formula bar is off. You need to go to the View menu here on the ribbon and enable the formula bar. And once you do, it remembers your settings. There's also this Advanced Editor button. So if I click on the Advanced Editor, I can see the full script of my query that I've just built up. So this is the full M language script. This you can write by hand. I find it's easier if you start with the UI, you start drilling around, and then go into the script and modify as needed. And so we'll talk about different scenarios and samples where you'd actually do that throughout the talk. Any questions offhand about Power Query? OK, let's jump over to the slides again. We'll start in on the language.
Great. So the Power Query formula language was informally known as M, or I guess is informally known as M. So you might hear it referred to as M. We'll actually probably even call it that a couple times. So design values, why did we build this language? The target audience is information workers and data analysts. So we're really focusing on the more advanced users in Excel, the people who are comfortable with using the Excel formula bar. And for these types of users, we wanted to make sure that the language was familiar and easy to remember. We want to make sure that it's a superset of what they can already do in Excel and similar to DAX, which is another language that is used in Excel. And we also want to make sure that while it's easy, that it also has the powerful capabilities for those users who really want to dig in and do more advanced features. So that's really what we're going to show today.
And so a common question we get is, why yet another language? Why do I have to learn another language? I know SQL, I know DAX, why do I have to learn M? And it is a very valid question. And so our answer is usually, you don't necessarily need to know M. Power Query does a lot. You can do a lot in Power Query without ever having to touch the language. It's more of an advanced scenario thing. And the reason why it is another language is because it's meant for data transformation. Talking with customers initially, especially ones who are very familiar with DAX, they kept saying, why isn't it just DAX? Just make it DAX. And once they start using M and seeing how the language flows, it starts to make sense. And now we have many M converts among the DAX community.
Great, so jumping right into the syntax. So syntax for simple queries in some of the other languages. So in SQL, you can see here that we typically select the columns and then choose the source that the columns are going to come from, and then you do your projection at the end. Then C# link and C#, you can see that we connect to the source, and then we do the projection, and then we select the columns at the end. So now comparing Power Query, which is going to do the same thing as the other two examples, you can see here we have a slightly different syntax. We have this let and this in, and in between we have a series of steps. And the order that we're doing in these steps, we are going to select the source, then we choose the columns, and then we choose how to sort and then transformations after that. So we're doing similar steps as you do in these other languages as well, but with slightly different orders.
Yeah, and the ordering is actually an interesting thing in Power Query. Because just because you write your query in this way doesn't mean these steps are actually going to be executed in this order. Okay? And there's a powerful capability within Power Queries where a lot of the power comes from. We call it query folding. And there's two cases where this comes in handy. One is when the query gets evaluated at runtime, the M engine is going to take a look and eliminate anything that's not necessary. So if you have some steps in there that are a duplicate, or if you do something on a column and then remove that column, it will just take it out and never select that column to begin with. Okay? The other thing it tries to do is it looks at all these steps that you're performing and tries to push as much of that work to the source system. Okay? And this is the process we call query folding. So in this example here, we are connecting to a SQL database and selecting, so AdventureWorks, and we're selecting dim product. We then say select two columns, and then we remove some columns here. So the transformation I'm doing here is actually selecting my columns. That was what the equivalent of that line. And then I rename one of the columns, the product column, and then I add a filter. So I'm adding a filter on the product key.
And this query was actually fully generated by the UI. So with the different screenshots, you can see Matt actually just clicked a bunch of buttons, and then this was the resulting script.
Right. And so the M engine takes a look at this and actually runs it at runtime. So it takes that original query that we wrote, and it will then fold this into a single SQL statement that gets executed against the source system. Okay, so even though you're doing everything, it seems like you're doing everything locally and in memory, Power Query will actually push as much of this work possible to the source system. So what actually gets filtered? Lots of things get filtered. So common things are column filters, row filters, group bys, pivot actions. What actually gets folded depends on the capabilities of the source system. So if you're talking to a relational system like SQL Server, a lot of the functions, a lot of the stuff you do can actually be folded to the source. One of the great things about Power Query is if you're talking to a system that can't be folded to, so you're reading from a text file, for example, Power Query will just do the work locally. So we say that there's no cliffs to the language. And regardless of whatever source that you're connecting to, you can perform the same sets of transformations. The other thing that affects folding is some internal Power Query logic, some optimization, so it knows when to fold and not to fold, and also data source privacy level. So if you're ever using Power Query and you're trying to join data between sources, you'll get a prompt. It asks you to select a privacy level for your data source, either public, organizational, or private. And this is to prevent you from folding, or prevent Power Query from folding data from, say, a private source to a public source. So for example, say you're doing a join of customer data with a public web service, right? You don't want Power Query to send your private customer data to the web service to make those calls. Right? So if there's an incompatible privacy level, Power Query will just do everything locally instead.
Yeah, so the last thing that affects folding as well is native database queries. So this is the feature that Matt was warning you about initially. So what are native database queries? This is the way to query the source directly. So for all of our relational data sources that we support, we have that SQL statement box that you saw when Matt was connecting to SQL Server. So why did we add this feature? Well, while we try to push as much of the work back to the source and try to figure out how we can translate M back to SQL, there are times when what we folded isn't as efficient as what you could write yourself. So that's one of the reasons that we offered this feature. The other major one is that people had existing queries that they were already using that gave them the data they wanted in the shape that they wanted. And they may not know how to translate that to M, or they may not want to translate that to M. So this was a way to let them access that data through Power Query and then interact with the other Power Query features as well. So there are important caveats to using this feature, as Matt was saying. The biggest thing is that any steps that you've done after that resulting data, those functions won't be folded back to the source. So that's a really big thing to keep in mind. If you're going to do anything that can be done on the source, make sure it's included in that original query. The other thing is that the query isn't parsed before we send it to the source. So whatever you write in there, it'll be sent directly to your database. And we can't guarantee how often the query will be executed. If you use Power Query before, you'll notice that we do different sets of analysis and during refresh, that sort of thing. So if you're doing anything besides just reading data through a query, you're going to want to be very careful.
Yep.
So a quick note on our library functions. I mentioned them or showed them quickly when we were looking at the syntax. So we have a ton of library functions, and you can look at the library spec at the link below, and we have some other links to share near the end. We kind of separate the library functions into a set of groups. So one of them is data access. So Matt showed you all the different data sources that we connect to in the UI, and these are our data access functions. We also have a large set of transformation functions. This is really the bread and butter of what the language can do. So lots of things like converting things from text, joining things, sorts, and we'll show them more as we get into our demos. But the transformation functions are really the interesting part of it. We also have this sort of other category. One of these that we'll look at is actually our set of our binary functions. So it allows you to read and specify binary types as well. So yes, take a look at the library spec for more information.
So not every button within Power Query, not every button has an exact function mapping. You'll see there's some duplicates. Like we have a connect to SQL Server and a connect to Azure SQL Database that actually you see underneath just calls a single SQL function. Other times there's some transformation buttons that map or call functions in different ways, even though they're labeled as different buttons. And there's also a lot of functions in the M language that aren't exposed in the ribbon. So it's something to, the library spec has a full listing of all those.
Great, so now that we've talked about the library, I'm going to jump over to a quick demo about when you would use this and what certain benefits. Okay, great. So here we are. I have 3 tables in my workbook that I've already connected to. One quick thing to note is that my load is actually disabled. Now this is really handy, especially as you start building up more complex queries. If you've used Power Query before, you know that you have options to load it to the sheet or load it to the data model. There is also another option to not load it at all and just create that connection. And that can be handy if you're going to reuse that connection in multiple things. This isn't the final shape that you want it in, so you don't have to actually load the data until you're ready to do so.
Yeah, and can show them the default, the new button now in the, if you go to data source options. So this is actually in the latest build of Power Query. There's actually an options now where you can set your default. So now I always turn my default to don't load because I typically will build multiple queries and I'll do query editing and stuff like that. I don't want to load the intermediate steps to the worksheet.
Great. Okay, so on one of my 3 queries, pretty much what I want to do is I want to do a 3-way join between these tables. And so Power Query makes this pretty easy. I have an option here in the ribbon to merge queries. And doing so will give me an interface that brings up the table I'm already on. It shows me the other tables I have in my workbook. And it makes it really easy to do a quick join. And so you can see down here, we actually tell you how many rows that make a match. And you can hit OK. And now what I've done is I've I've done a really quick join, and it's landed in this new column in this nested table format here. One of the things I can see in the formula bar, so this is one of the reasons to turn on your formula bar early, because you can start seeing what's generated automatically. So you can see here that it did a nested join, and it has my key columns and that sort of thing. So one of the things, to be a little bit more efficient, I'm going to choose to do a flat join instead. And a great feature that we have here is actually to give you more information about the functions that you're using. So let me zoom back out. So pretty much you just specify the functions without any parameters, and it's going to show the function help right in line. So I can see here that table.join is a little different than the table nested join in that I need to specify a join kind. So instead here, I'm just going to write, let's do an inner join. And with that, I've done one flat join, and I have all my columns visible. So at this point, I'm going to show you, that was a basic way to just use a little bit of M to make it a little bit more efficient. But hopping into the advanced view, you can see what I've done here. So the first two steps, here I'm actually just connecting to my source and choosing what I want to select. The next one is actually choosing the table that I've connected to, and then our last step is actually doing the join, you can see here. So this is on top of the other two queries that I've already imported, and if I wanted to do yet another join, I would have to add another step in line. So we can make this actually a little bit more efficient. I'll hop over to something that we built for you today, pasting it in and zooming back in for you. So you can see here the initial part is the same. I'm still connecting to my source, but now the next 3 lines are actually connecting to those 3 different tables. So instead of doing it in 3 separate queries, I've optimized it and done it in 1 query initially. And then you can see my last 2 lines are the 2 joins, again in line, and I can hit OK, and I actually have this 3-way join connecting to the tables and then joining them all in 1 query instead of having 3 or 4 or even 5 queries.
Right, and so even though it was done in multiple steps, underneath this would be a single SQL statement that gets executed against the backend SQL server.
Exactly, so that's one way to use M to make things just a little bit more efficient.
Yeah, and if you were joining different disparate data sources, like you were joining 2 tables from SQL and 1 from a text file, it would join the 2 from SQL server and then do the text file join in memory. Language flow. So if you see the code as we wrote it, we talked about how the language flows from one step to another, except when it doesn't. So if we look at this example here, right, here we are connecting to a web source where then and assigning it to the variable source. And then in the next line, we're then indexing, so grabbing actual data from that web source and assigning that to a variable called web table. And then the following step, we're going to rename one of the columns from web table. We're going to rename column 1 to rank and column 2 to 2013. Assign that to rename column, and then the final in is basically like a return statement. So we're saying return rename columns, which is the final step. Okay, so this is a case where you see it flows from one step to another. And this was the main thing I had to wrap my head around when I first started writing M. I didn't really understand the structure. It's a bit different from some other programming languages. But if you think of it from a data transformation point of view, it makes sense, right? Your values typically flow from one step to another, except for when they don't, like we do in this join example. So here I'm defining my source step and then using source multiple times. The first source grabs the category dimension. The second one is the subcategory dimension. The third grabs the customer dimension. Then the final step there, I am going to join subcat and cat. And notice I never actually referenced the dim customer. When the engine evaluates that, it would just strip off that step entirely and just never execute that because it's never actually used. So if you change the in, like if I had the joined in and just returned dim cat, it would never execute the join. It would just return you the product category table.
Yeah, so the language tries to optimize whenever possible.
Yeah. Any questions about that? OK.
Great, so on to the type system. So we do have a small set of built-in types. We have this notion of any, which is really any type if we can't really detect what is in it. We also support null, logical, number, text, and binary. So we didn't blow out number to things like int 32 and 64. Our only explosion around types is around dates and date times. You can see we have quite a few here. And that's really to represent how complex those data types are. We also have more complex types, such as lists, records, tables, and functions. And we also allow users to define their own.
Yeah, so M is a loosely typed system. There's not much runtime type checking. Where types really come in handy is when you're writing your own functions, because the UI, when we talk about functions, we'll show there's an invoke button anytime you're dealing with the UI. And the UI will provide some validation. So if you say that this function requires a number field and the user types in text, they'll get a validation warning and things like that.
Yeah. Without the UI, you wouldn't know that you have the wrong type until you actually try to evaluate, and then you would hit a runtime error.
Yeah. So as someone who's writing M often these days, the only time I really use types is when I'm doing functions and declaring functions. So this is a quick example. I use this slide for reference, but the different types, and we have a type demo coming up. We're talking about lists and records and tables, and then you can actually create functions as well.
So here are a couple more reference slides, starting with simple values. So this is the types in the literal format. We have some more complex functions that you can use. You can convert these all from text, or you can use this sort of shortcut here where you see pound date or pound time. So this is actually more complex values. You can see here we have lists, records, and tables. So use these slides for reference. So I'll do a really quick demo of types. So one of the things that we have here is actually a blank query. This lets us just start from scratch. So zooming into the formula bar. So lists are pretty easy to deal with. You can see I have a shortcut here. This is going to generate a list 1 through 10. So lists you use with the curly braces. And you can see here the UI figures out that I have a list, and typically you want to convert these things to tables. So that would be an easy way to do it. So next, looking at records really quickly. Records are with the square braces, and you usually have the name and then the value. And you can have multiple items within one record. And now you can sort of combine the two. So you can have a list of records, for example. Yep. There we go. And then you can see here that it actually builds my list of records. And again, I can convert this to a table. And records and lists of records, they don't actually have to be homogeneous. So you can have a different set. You see this has no X value. So I can convert it to a table and then actually expand it. And you can see it's going to build out that table for me. And it put a null value there where I didn't have one. So zooming back out, you can see over here in our applied steps that actually took a couple steps to convert my list of records into a table. So sneaking back to the source, of course, there's an easier way with the language. So we have a function that will do this, table from records. And it just takes a list of records just like this, and it's going to build up my table. And now you can see my last line has an error, and you can actually click into the cell and get a preview here of what the error is. And it's because, again, tables do expect your records to be of the same shape. So just adding that X value will build up my table as expected. So that's just a quick example of how our different complex types work together within Power Query.
Yeah, a common thing I find when I need to build my own tables or types into my M script is if I want to loop over a list of values, or I have a hard-coded range of things that I need to do. So I'll typically build up a list in M and then invoke functions for each of those things in the list.
And you'll actually see us do that a little bit later.
Yeah. Okay, so this is the most complicated slide of the deck. So unary functions. So a unary function is a function that takes in a single parameter. And you're going to see this quite often in M, especially around tables and rows. Okay, so in this case, we're doing a table.selectRows. You're passing in a table argument, so the table argument is typically your previous step, right? The transformation's up to that point. And what this function is doing, what the table.selectRows function itself takes in a table, and then it takes in a lambda expression, so an expression that is going to be evaluated per row. The R argument there is meant to represent a row. And basically, it's saying, pass in the row, and for each row, compared the manager column to the buddy column. And if they're equal, select that row. Okay, so basically, this is going to be invoked over every row within that table argument that you just passed in. So there's a shorthand way of writing that. Because this is done so often, M has a shorthand with an each function. So here we can say table.selectRows, pass in the table, we do each, and then we have an underscore there, an underscore to represent the current row. So each is basically a shortcut into calling it. And because to be closer to the DAX syntax, you can actually eliminate the underscore completely. So in the shortest shorthand form is this bottom one. So these three expressions are actually similar, but you'll see in the UI when you do different operations, you'll see it looking like this. So you do pass in the each, which replaces the unary structure up above, and then you can reference the column names without actually having to specify the underscore. If you write your own function that takes in a row, you'd pass in underscore as the argument for that function. OK. This is another quick for reference slides about the top one you'll use often, the if, then, and else, right? Standard if and else expressions. The let expression, which is the general structure of how you start and end your M statements. Then you have error and try. So error is like throwing an exception. Think of it in C# or any .NET language. It's like throwing an error. So you get to a case, you could have an else error, and that will elevate the error and error message. And Power Query has some special handling on how to display those types of errors. And you also have a try expression. So that think of that as like a catch. So if you want to perform an operation, you can wrap it around a try and an otherwise to catch the error, so to hide it or to return a default value if an error occurs.
And this is probably a good time to point out that the language is case sensitive. So you'll see here we have if, then, and else all in lowercase. So that's something you'll want to keep in mind, especially as you're naming your own queries and functions and stuff, that when you reference them, it's all case sensitive.
Yeah. OK. So the rest of the session is pretty much demo. So we went through the slides really quick. We'll take a bit more time on the demos, and we welcome questions if you have any questions throughout. We have plenty of time left. So,
any questions now, actually, before we hop in? You guys still with us?
OK.
Great.
Yeah, either they're still asleep, or it completely makes sense. We have some pro programmers here. OK, so which should we do first? Yep.
Oh, yeah.
So the question is there anything we're showing here, does it work in the previous version of Office? So Power Query itself runs with Office 2013. It also works in Office 2010. So the add-in can be installed for both.
The only difference would be the load to data model option. If you use Power Pivot in 2010 as the add-in, you can still connect to the data that you've loaded from Power Query, but it won't be an option in the UI as it is here. You'll have to actually go through Power Pivot and pull it in. So that's the only difference.
OK. Any other questions before you jump in? Yep.
It seems like in some cases you're referencing columns as literal strings, but in other places they're more strongly typed. Am I correct in that? And then is there any sort of IntelliSense going on here, or?
So the question is, it seems like sometimes we're using like literal or string representations of columns. So like quotes, other times there's square brackets around it to reference the column itself. So typically the strings means you're referencing the name of the column. So you'll see that as like remove columns or rename columns. It's always done by name rather than ordinal, like an ordinal position within the table. And then the square brackets are usually meant to denote the value itself, or the value in the column. IntelliSense isn't there yet. You'll see that through our demos we have a Notepad++. We have a Notepad++ language file that we use for some highlighting and stuff. We could share out this language definition afterwards. So you can download, try it. You at least get some syntax highlighting. This is usually what I use as I'm writing. I can imagine that IntelliSense would be a feature that we'd add in the future. So IntelliSense and syntax highlighting directly within the Power Query editor. I'd love to see that. OK. So I'll do a couple of quick common scenarios that you do in Power Query. So if you were at yesterday's session, you saw a couple of these things, a couple of these steps. Common thing here is to connect to a folder of data. So here I have some sales data and spread across multiple files. So I have a headers file, and I have years of sales data spread across multiple files. And there's a cool thing you can do in Power Query where I will connect to the folder. I can list all of the contents of the folder. And under content, there's this magic button. It invokes a function called binary.combine. It's going to basically combine all these files together so they can be parsed as a single unit. Okay? Single one-click button. And if I click that, Power Query is going to auto-detect. So I've only done 2 steps, right? I connected to the source and I click that one button, but you'll see there's actually multiple steps here. So that's the other thing the Power Query editor can do that you don't get automatically when you're coding by hand, is it will auto-infer steps. So I click binary.combine. Power Query saw that it was CSV files that you're importing, so it added that imported CSV step. It detected that the first row was probably headers, so it inferred that other step. And then it detected data types. Right? So this is another case where starting off things in the UI and going through these steps, it's quicker than actually having to write all this stuff by hand.
And you can see in this case, it was super helpful to just have that one button that combined them all together, because we had 4 or 5 different files that were supposed to represent sales data over a certain amount of time. So it's the same schema, same type over multiple files. And instead of having to connect to each one and then sort of append them together manually, in one button, it figured it out for us.
Yeah, so it just went through and loaded all 60,000 rows of data here. And if I scroll down, so I see I have the 2005 data, and as I scroll down, I can see the other years of data was imported in, right? Really handy.
Quick question, yeah.
So the question is, if there's inconsistencies around the 2 files, no. So it's just doing a very straight binary combine, so you have to make sure that the files are in the right format. The best case, this is like the happy path that I don't usually talk about. The best case is you actually have your headers in a separate file, because otherwise you'll get headers repeated in every file. There are ways to handle that in M. You can say remove rows, or you specifically look for different things to take out. But yeah, the happy path for doing that binary combine is where you have separate headers and then all your data files. Yeah. So a question is, so I showed this because the common question we get is, can I do this with XML files? Can I do this with Excel files and stuff like that? So that's going to be my next demo.
You jumped ahead.
Yeah. This was actually, the last conference was at, SharePoint conference I was at, this was, somebody was actually criticizing, saying, well, yeah, you can do it with flat file, but we always use Excel files and you can't do it with Excel files. So I'll show this same process and how that's done with Excel. Of course, Excel is a structured format. You can't just do a binary.combine, right? You can't just glue the files together and parse it in a meaningful way. So I'll show you the process that we do here.
Yeah, so Matt just went through the easy one, the happy path, as we like to call it. In the more advanced case, you have to do a little bit more magic, but it's something that's still pretty straightforward, and you don't need to know a lot of M in order to get this done.
Right. So I'm going to do from file. This time I'll do from Excel. I'll paste in my Excel file. So I'm going to start with just a single one of those files, and I look inside, and I have sales data. Edit this. So in this case, I'm looking at my sales data. I see that my headers are in the first row, and I will do use first row as header. And then I'm pretty happy with the way this thing looks. Again, this is loading a single file, so I'll call this function getData. Now, if I go to the advanced editor, I can see my whole code here, right? Now, I'm just going to show you how to turn a regular query into a function. It's actually pretty simple. I do this. So open and close braces, and then I have the equals, what is that called? Greater than, in my function, and now it's a function. I click done, and now you see that the UI has switched it from a query result to a function that I can invoke. If I click invoke, it runs that function. Now, not that exciting. It just did exactly what I was doing before. It gets interesting when you start parameterizing your function, though. Right? So now if I add a parameter called file as text, right?
And the as text is how we type that parameter?
Yeah, and typing is actually optional, so I could include it without that. And I replace this, my actual data here, and I slide this over a little bit, with that parameter I passed in. Right, now I actually have a function that I can invoke with a different path. Okay.
So pretty much it's going to take the parameter and then it's going to do all the same steps that he had done on that first file.
Yeah. So I'll call that getData. So now I have a function that's able to take in a path and parse that Excel file given the query that I actually built. So now it's time to invoke that. So I'm going to do from folder again, and I will take this directory. So now I'm listing all of my files in the directory. I don't want to do binary combine this time. Actually, what I want is the full path to the file name. So I'll get rid of this column. I'll move folder path over here. I'll get rid of these extra columns. And then I'll merge these two things together, which is on this, merge columns, no separator. So now I have an argument that is my full file path. I'll call this path. Now I will insert a custom column. And that custom column is going to call the function getData.
So this dialog might be the first place that you actually write some M. So really basically he's just invoking his own function with the column path.
Yeah. Click OK. Now I have a table for each column, or for each file. I can see it down at the bottom. And I can expand this inline. And now I have actually invoking over every file I'm going to load for each file to my worksheet.
So a couple more steps, but it's still possible, and it was actually quite easily done. And especially when you're writing your own parsing script, that's the point where you can start special casing certain things. So for example, if you have a combination of CSV that are comma delimited and semicolon delimited, you can actually detect which way to go and split based on the column type, for example.
Yeah. We have a question over here. Could we do this as well in VBA? So currently, Power Query does not have a VBA interface. But as we get tighter integrated in Excel, I can see us adding that. No, currently there is no VBA interface for Power Query. Yeah. There's a question? So currently there's no automation interface at all for Power Query. It's strictly through the UI. You can write the language and paste it in, but there's no way to automate using VBA or C# or any sort of language to do this at this point. I can imagine that coming. Just like currently Power Query only runs in Excel, the language has to run in Excel. I can imagine in the future that we'd be taking that and running in other cases as well. Running as an SSIS source is a really common ask that we get. Right? You can imagine seeing this transformation capabilities as a source in SSIS and going into the rest of your data flow. Definitely a handy scenario. But I can see other cases where this could be used as well. So the question is around if you want your user to actually select, like you want the user to select a directory of data and then perform a set of operations or run a set of queries. Right, so the user would actually have to do that. You could give them a function, share a function through the Power BI functionality with the function sharing. You could actually share that query and users could consume it. And then it's just a matter of them clicking that invoke button and passing in a path. Right. There's another question back there, or did we answer a question there? The question is going to be a published roadmap about Power Query itself. I think maybe some of the bigger items that we can follow along. So Power Query has been very on a rapid release cycle. We do monthly updates. If you started using even a couple of months ago, you'll see that the UI keeps improving. The language itself doesn't change as often. Most of the improvements we make are more around user experience rather than major things. The main language changes have been around connecting to new data sources, although we do add some new functions. I'm not sure if we plan to post a long-term roadmap. I think it's actually hard being on the team because we try to remain agile in what we actually go. We basically try to tackle the biggest customer demands each month. Right. Yeah.
Great. Any other questions?
Okay. There's one thing I want to call out. So you'll notice that even though I typed in, right, I just typed in that get data, you'll notice that each was inserted. So every time you do the insert custom column, Power Query inserts that each for you to basically say, for every row in the table, invoke this column.
And you'll probably notice it as well if you're leveraging other functions that are just shown in the ribbon. You'll notice that each. So next time you turn on your formula bar and you start playing around with it, when you see that each, go back to Matt's reference slide and figure out what the heck's going on.
Yeah. And actually, so going back to that question about whether or not you can ask the user to select, you could actually have another function that invokes this function. So you could parameterize this main query that takes in the directory and then goes into the directory and parses all the files. You could parameterize that as a function as well and prompt the user to input a folder. So yeah, every time you create a query, queries can reference other queries, functions can call other functions, so as long as it's within that workbook.
Great, so the next, question, yeah.
Yeah, one more. So the question is, where are the queries stored? So currently the queries get stored within the workbook itself. So you need to take it, it's between workbooks. Power Query itself, Power BI, if you have a Power BI license, there's sharing capabilities. You can actually share a query. We have limited support around sharing functions. We plan to improve that. But you could share a query as well and then consume it through the search experience. And I think we can show that in the next demo.
Yeah, and so when you share it, we'll share out that script that we were showing you, so we don't actually share out your data. But then anyone within your organization or you from any machine can then find that query through the search functionality and use it in other workbooks.
Okay.
Yep. No, so when the question was, if you share a query that's dependent on another query, do you have to share both of the queries? When you share a query, Power Query goes through and analyzes what it's dependent on, and it will actually package everything up so that your consumer has everything they need when they consume it.
Yeah. Okay.
Okay, hopping over to the next one. So,
yeah. This is actually a demo at the booth that came up. Somebody asked me about this. How can I go through a list of airport codes? I have a lot of different data. How can I bring this into a single list? So we decided to turn that into a demo today.
Yeah, so hopefully the person who asked the question is actually here today.
Sitting right at the corner right
now. Oh, great. Great. So you can see here that Wikipedia has a list of airport codes across the whole world by letter. And you can see that each of the letters are separated. Let me zoom up here. So they've separated it over multiple pages and just indexed it by page. So if I switch to B, you'll see that it's B at the top. So we actually figured, let's show you how to connect to this in Power Query. We want one big list. We don't have to connect each time. So I'm going to grab one of the URLs, and then I'm just going to go from web. You can paste it in. And we go back to Wikipedia. And it's going to parse the page, it's going to identify any tables that are there, and then show me my options here in the navigator. And so hovering over them, I can see that this first one looks like what I want, so I'm going to edit it. And one of the interesting things that I noticed right away is you can actually see back on the original page that it had this header line that spanned multiple things, and it does it a couple times throughout the page. And so typically this would be kind of a pain to use in data, but the way that we detected it on the table, we actually created a whole row, a whole column that had that value for every row. Then you can see that we got the different headers as we parse them out.
Yeah, that's one of the really nice things about the Power Query CSV parser that wasn't immediately obvious. I just found out about it last night.
Yeah. So I only need these 3 columns, so I'm going to remove the other ones. And this is pretty much it. This is all the information that I'd want, but I want it over all of my different fields. So I'm going to do similar to what Matt did, and I'm going to make this into a function. So zooming in, you can see here that I have my web page, and this is really what the parameter that I would want. So instead of having the B or A or C hard-coded in, I'm going to specify it myself. So I'm going to insert, I'll call my parameter letter, and then I'll do the trick that Matt showed you and create this function saying that the letter is a parameter. So I could keep it like this, or I could add the fact that letter should be a text. Great, so just like that, I'm done. And again, just to show you that it's actually going to do something, I can invoke it with C, and then I get the information that I want. So let's rename this something helpful, get airport codes, and then I'll save it out. So now I want to do similar to what Matt had done before. He got the list of what he needed and invoked over it. So maybe I could generate a list. One of the things I know in our search capabilities is that we have a bunch of different data, and the list of the alphabet should be pretty easy to find, right? So looking for the alphabet. This is searching in our online public catalog. We were talking about sharing queries before. That would be in your corporate catalog. So we do have different information that's stored in these different places. So again, you can hover over. You can see this is also from Wikipedia. And I could use something that helps you pronounce the alphabet, or this one looks pretty straightforward. So selecting it is actually going to create a quick query. And then editing my query, you can see I have A to Z. And really all I need is this one column. I don't need the other information, as interesting as the frequency column is. So let me remove my other columns. And now I have everything I need, and I just want to invoke the function over top of it. So one of the things that Matt showed was actually creating a custom column that added a column to my table and did the function there. Another option would be to use another function that we have, which is actually called table transform columns.
Yeah, so the main difference in these two approaches is, in mine, I added a custom column, then I had to expand. In this case, we're actually going to transform an existing column into the end result.
So again, using that inline function help, I can get an example right there if I don't quite know how to use this. And you can see the different parameters that are expected. So let me paste it back in. So one of the things I know is that if I just have one column, I can offer a default transformation. You can see it right underneath. And actually, all I want to do is leverage the function I just wrote. So this is my own function. You could do something else like one of the other library functions we have. You could use SQL.database if you're going to pass in your server name, for example. So just hitting enter here, you can see now I have my list of tables. And in the same step, I can expand it. And I have everything I need. And we go A, B, oh, lots of A's, B, C, and it's actually filled them all up together. And so at this point, you could take it and you could split out the country, for example, and map it, and you can see different information. But really quickly, we found something online that was helpful, and we got it into a form that I could actually use it and keep working with the rest of my data.
Yeah, and I realized we forgot to call it one thing. So if you want to zoom in on the FX button that you click, so you can actually, to add a new step manually, you can click that FX button. Once you do that, then you can start typing in your next statement.
Yeah, and so what it does when you select the FX button, it auto-generates a step that actually just references the previous step. So that's a quick way. Typically, you want to reference the previous step as you're typing your own function. So that's a quick way that it auto-populates it. If you don't do anything and you actually just hit enter, it'll show the result from the previous step again.
Yeah, and if you show the advanced editor, just show what that looks like. See that? So Power Query auto assigned the name custom2 there and just had exactly what you had in the formula bar right there. That was the other thing that threw me off. When I add a formula bar, or sorry, manually add a formula, I thought I had to name it as well, but you only do that on the advanced editor.
Great. Any questions on that?
Okay.
Awesome. Switch back over.
Great. So now we had this great demo. We're
Too close.
can never stand close to each other. Okay. So we actually have some time, so maybe I'll show this. So Faisal and Miguel showed this in their demo yesterday. So maybe just quickly I'll show it. So this is very similar to my demo where we were parsing the Excel files. In this case, I'm parsing some web data, and the data is paged over multiple pages, right? So every page has about 100 results on it. And so I'm going to connect, and I want to basically read all these pages together, and I'll create a function to do it. So let me do this. So again, just like the Excel, I'll connect to this page, to a single page at first. It connects to the page. It's going to pull out everything that looks like a table. And this is the one I want. It looks fine like that, except if I scroll down to the end, I can see that there's some summary rows at the bottom. Now, we used to have some complicated steps here where we would do a total row count, where we'd just take the first top 100, but that doesn't work because on the final page, there's not 100 records, and you still have it, so you have to add table.row count. It was a great part of the demo. Unfortunately, we added a very easy-to-use button, say just remove bottom rows, rather than keep top. So it broke our demo. But now it's very easy. So I'm just going to strip off the last 3 rows of this table. So that gives me a single table of data. I'm going to turn this into a function again. Open this up. Say page as number this time. And then I see within my query string here, I have a page parameter here. I'm going to add this in. I'll do number.toText. Power Query doesn't automatically convert number values to strings. So because I want to treat it as a string, I use the number.toText function to do this conversion. Finish my function right there. Done. Now I can invoke this over multiple pages of data. Let's just test it. Pull back page number 1. If my internet is working. There we go. OK, great. So now I know this function is working, and I'll call this getData. It's my favorite name for functions. OK. Now I want to invoke that over all my pages. And in this case, if I go back to Box Office Mojo, I see that there are 7 pages of data, and I know how many pages there are here. So I'm going to do from blank query. Whoops, not SharePoint lists. I do from blank query, which lets me start off with a completely blank query. I will do 1 to 7. So it'll give me a list from 1 to 7. Convert to table. I'll do my insert custom column trick here. Call this getData. Pass in column 1. Great.
This is another example where in a few clicks and a few extra things that we typed in, we've really easily gotten to the data table that we wanted in the end.
OK. And I can actually remove this first page thing here, because I've already used it to invoke the function. I click apply, and actually I forgot to actually turn on my query, or to load the query. So I'll load this to the worksheet. Click apply, and now it's going to pull down all that different data. So again, when I first showed this, somebody challenged me saying, well, this is great if you know all of your maximum range, right? I can look at the page, and I know that there's going to be 7. So what do you actually do if you don't know? And this M was very hard for me to wrap my head around. I couldn't actually figure it out myself. But it's possible. I was actually amazed at the power of the M engine. So in the end, I pulled down all 686 rows of data. I'll start here by showing the code itself. OK? And hopefully this shows up OK. So here's the function that I'm going to use, or the M query that I'm going to use. I'm actually assigning a page range from 1 to 100,000. And then I'm using that list.transform function, passing in my list, and then I do a try. I say for each, so for every item in the list, I'm going to call getData, which is my function, and pass in the value, or the row. And if I get an error, so if I end up accessing a page that doesn't exist, it gives me an error, I'm just going to return null. Okay? So if I just ran these 2 lines, it would basically go from try pages 1 to 100,000, make all those requests, and I'd just get back null for all those things. But I don't want to make 100,000 web requests. I only want to make requests for the pages that exist. On this next line, I'm doing list first n. I'm going to take the first n records. And the predicate that I pass in is null. This is not equal to null. So basically, I'm saying take all the records until you hit a null. Okay? And then I convert it to a table, and then I expand the table, and then I end up with my query. So the M engine has an optimization here. When I'm actually doing this call to get data, it actually returns a promise for data. It's not actually evaluating. The M engine knows I'm going to, at some point in the future, you're going to ask me for this value, and I'm going to have to run this for you. Then it sees that, OK, I only have to ask this value, keep asking for these values until I hit my first null. So when I actually evaluate this, it's not going to make 100,000 web requests. It actually makes only the first 7 requests. It gets a null on the 8th request and stops right there, because I did give me a call to the first. This hurt my head a lot when I tried to figure this out. But
the same guy who challenged you to handle this also asked about, well, what if there's actually data on the 8th page and 10th page, and if things are a little sporadic. So you could do a similar thing. If you don't use first n, though, it would do all of the requests. So if something more could be anywhere up to 100, for example, then you could just choose to select the rows instead of using the top rows. But there's different options depending on your scenario.
Yeah, so if I pull this back, it's going to pull back my data. And if I say load to worksheet, it will now execute and then will stop once it hits that first null record.
So that was, again, a couple clicks. We wrote very little m in the easy case that you likely have seen before. But then there's a more advanced way that you can actually connect to even more data.
Yeah. OK, any questions around that? Nope. OK.
Great. So this next one is one of the most advanced scenarios, actually is the most advanced scenario we're going to show today. So one of the things that we found, I mentioned earlier in this sort of other group of library functions we have, is our binary functions. So this is a way to define and read binary sources. So one of the things that we found actually as we were working on the team and leveraging Power Query to do a bunch of different things is that in some scenarios you have these sort of custom binary blobs that your system is producing. So for whatever reason, it's building a specific blob that doesn't have any way to read it. You might have built a custom reader or that sort of thing, but you can actually do that in Power Query as well.
Yeah, I had this scenario recently with an internal team where their web service was, for historical reasons, was encoding a bunch of fields as a single blob, a single binary format. And by using these binary functions, they were able to break out the values that they actually wanted to put into the workbook so they could report against it. But previously, they'd have to write some custom VBA within Excel to decode the actual data.
So we'll start with a simple example so that we can kind of follow along with how something like this would work. So you can see here that I have 3 components to my query. The first one is the source, and I'm using our pound binary shortcut in order to define my binary blob. So I have my binary blob, and you can see that I have all, it's a set of bytes in the binary. The next one is actually defining what's within this blob. So I know that within my binary source, we're going to have points. And you can see here that I'm saying it's a record that has 2 2-byte values. So I'm calling them X and Y here, but you can see using this binary format, I'm saying that within my record, I have 2 2-byte values. Great. Everyone with me so far? Awesome. The next one is this file format, and this is actually where the magic happens. So what I'm doing here is using one of the more advanced binary functions called binary format.choice. This is pretty much saying how we're going to parse out the blob. So it's saying use the first value, which is a 4-byte value. Use that to figure out how many records I have within my blob. So if you go back to our actual source here, you can see the first 4-byte value is just 2, and so it's going to say that I have 2 records within my source, and I already know from our point format value here that each record has an X and a Y value. So seems pretty straightforward. Let's see if this actually works. So I'll copy it back over, use a blank query, and I'll paste this in. And just like that, the result is 2 records, just like I said. And now I can actually convert this to a table and expand it out. And you can see here that it detected, it followed exactly what I said, and it found those 2 records with 2 values in each. Great. Everyone following along? That seems pretty easy, right? Then again, our binary source wasn't too complicated. We could even edit the source, for example, and add another value, 3 here, and then add an extra record, and it would still parse it out just like you're saying. So a much more complex version, this seems helpful, but how often do you have a little blob like this? Something more common and that we use as an example is actually this one here. So let me copy this whole thing in.
So this is the M code to parse a PNG file and load the header out of a PNG file.
So what we had is actually the member on our team who built up this binary format library, left us with this really interesting example that parses out a PNG file. So I can't even tell you all the different crazy things that go on here, but you can see all of the different functions, the different chunks that it's going to detect within this PNG file, and it's going to break it out into information that we can actually see in Power Query. So Matt and I were actually just at PASS-BA in San Jose last week, and so was the president. So you can't really see it too well, but I'm sure he's in one of these dark vehicles up front. We took a picture from our hotel room and figured that this would be a pretty easy picture to give you an example of. So we're actually passing this into the function, and I'll hit done. And you can see here that it's detected it as a PNG, and it's going to give the chunks that it detected within the function as a list. So now I have all the different chunks within. And actually peeking into one of the records, this first record happens to have the width, the height, the color type, that sort of thing, of the actual picture. So it's breaking up the binary, parsing it through, and giving us the data that we're looking for.
Great.
Great, yeah.
So I think that's it. Any questions? We'll go to some tips and tricks, and then we can wrap up.
Great.
Great.
Everyone's head's hurting from that binary thing.
Yeah. OK. So we've called out some of these tips and tricks throughout the talk. Really, this first one I find is the easiest, is where, especially when you're first learning them, use the UI wherever you can. The auto inference really helps. Seeing the different formulas that get generated per step helps you learn the language as well.
You can actually see in the demos that Matt and I were showing, most of the time we did most of the stuff through the UI. So we were parsing our Excel file or our web page or everything. We started in the UI and generated all our steps. It wasn't until we wanted to do something a little bit extra, where we wanted to optimize or do things all in one query, that we actually started typing. So
yeah, and so the thing about the library functions, and maybe we can show this real quick, but there's a keyword that you can reference, which is #shared.
So this keyword is actually very handy, especially as you're starting to learn the different library functions that are available. So typing #shared into the formula bar is actually going to give you a list of all of our different functions as a record. So converting this to a table is usually the first thing that I do, because then you can search through them, for example, and say, find everything that has a table, and then you have all your table functions there that are easily accessible. So this is something that's really helpful, especially as you're starting to learn the function. We do have other reference documents, both PDFs and web pages that you can navigate through. But sometimes when you're in the middle of doing something and you want to know, #shared can be a quick shortcut.
Great. And as we showed, you can type in the function name and it displays the help. And actually, in that #shared thing, you can click on that function link, and it will do the same thing. It would be just like invoke it. So for troubleshooting, using try and catch, using the try and otherwise, it's very useful for debugging certain things that might throw errors, and actually catching and inspecting the error object as well. Power Query does have a function that lets you remove all error rows as well. And if you're doing something and you suspect there's an issue with the folding that's going on, like with the query folding, what Power Query thinks it's going to send to the source system, there's a function called table.buffer. And if you do table.buffer, Power Query will fold up until that point. So say you want to do it halfway through your transformation, you do table.buffer, Power Query will fold up to that point, bring everything into memory, and then the rest of the transformations will be done locally.
And this is really useful for other things besides if you think that there's an issue. For example, if you're connecting to a source that's very slow and you're noticing that the requests are taking quite a long time, you can insert this cache point, and we'll do everything locally from there on. Now, typically, you'll want to remove that cache point before you fully load everything. We will refresh up to that point, so it's up to you. A similar thing with, for example, selecting rows with errors. That can be nice as you're developing up your query and getting to the result that you want. But unless you want a query with just the errors, you probably want to remove that step before you load everything into your sheet.
Some links for you. So a link to actually download the Power Query add-in. It's an add-in for, like we said, Excel 2013 and Excel 2010. There's some links for the library, for the language as well. There's two reference specs. One's for the language itself. It's going to be about the structure, if statements and let statements, and what that's supposed to look like. Then there's the language reference, or sorry, the library reference, which is about the library functions that you'll use, helpful library functions. And that library reference is now available in the Office help as well, so it's a web-based version rather than a PDF version of the language spec. So you can search and see individual functions listed there as well. Great. Some related content. If you missed yesterday's What's New in Power Query session, be sure to check out the recording. And a bunch of stuff coming up. I expect there'll be lots of Power Query in the session following this, or the BI Power Hour, which I'll be presenting in. Stick around for that. And that's it. I'd like to thank you very much for coming out, some track resources, and I'll just put up the eval slide so you guys can take the picture.
And then we'll take questions.
Yeah.
Thanks so much, guys.
Thanks very much.
Any questions?
Nope.
Yeah. Sorry, could you repeat the question?
I think the question.
How does it play into Power? Yeah.
Yeah. So at the beginning, we talked about how you use Power Query to get the data in. Right. Typically, you'll put either to the worksheet or you'll put it to the data model. Usually, if you're using Power View, so Power View is more for visualizing it. So the steps is usually Power Query brings the data in. You use Power Pivot if you need to add additional data model aspects to it, and then Power View to do the visualization. Does that make sense?
Yeah, so they're all connected, and then they really complement each other to get to your final goal, if it's visualization or modeling or whatever you need.
Yeah. Question? So the question is, if you're using Power Query to load to Power Pivot, and you want to elevate your Power Pivot model to a tabular model, what happens? Today, it's not a very good story. It actually doesn't work. So Power Query doesn't work with tabular. That's one of the next things we're going to be working on. So yeah, it sort of breaks that grow-up story for Power Pivot. You'd have to recreate your connections using the SQL or whatever direct connections that tabular supports. One of the things with Power Query, so we released it as an add-in initially. Now that we've gotten this great feedback and people seem to love it, we've convinced that the Office teams that this should be tighter integrated into Excel, and the BI teams that this is part of the Power BI suite. So we need to, next step is basically making it work with tabular and integrating it closer into Visual Studio and things like that. So the question is, can I save a query? Yeah, so it's copy and paste at this point. There's no explicit save. If you save, it will save to the workbook itself. To extract it to something else, you open up the advanced editor, copy and paste that into Notepad, into something else to save out.
Yeah, and if you keep it as a query within the workbook, that means that it's always refreshable as well. So if copy and paste it if you need it maybe at a point in time, but typically you want to keep it in the worksheet so that you can hit refresh and get the latest and greatest. Yes. Yeah, so the output, it's only copy and paste like you said, but so it really depends on where you want to use it.
Oh, the data that comes back.
Right.
Yeah.
I thought that's what you meant by copy and paste.
Oh,
the result.
I meant copy paste the query itself.
Oh, yeah.
Sorry, I heard query. So yeah, the data itself, it goes into your Excel workbook. Then you can save as CSV. That's usually the usual way that I do it. Yeah. So the question is, do I have scheduling capabilities, or can I schedule it? So every Power Query that you create is an Excel connection, and it runs like a regular Excel connection. So you hit F5, and it's going to refresh it. Through Power BI, you can deploy to SharePoint, to the BI sites, and there's refresh capabilities there. If you just want to refresh it locally on your machine, you can use the Excel automation APIs to open up the Excel object, do a refresh all, and save it again. So it plugs into like any other data connection within Excel. Okay. Any other questions? Yeah. Do you want to handle that one?
Sure. So how much memory it consumes, it's whatever's available on the system. So it will it doesn't have a max of amount of data that it can process short of what's are the resources on your machine. So there's pros and cons to that. But right now there isn't a way to offload some of the work. Right now everything is hooked into Excel and on your machine. But you can see, especially as we start dealing with larger data sets and having big data support and that sort of thing, that we're going to need to work in some way to offload some of the work from your machine. So it's not something that's available yet, but it's something that we're looking into.
Yeah, typically where you'll hit the memory issues, one is if you're using 32-bit Excel, so I recommend using 64-bit. The other is
Your mic's off.
Because Power Query tries to, yeah, my mic is low. Because Power Query tries to fold everything, right? A lot of the time the work is offloaded and pushed to the source systems. Times where you do a lot of, where take up a lot of memory is if you are joining large data sets locally, that folding can't be done, large text files and things like that. Power Query tries to stream as much as possible, but some operations it's going to have to bring everything into memory. So the question is there any way to see how much data is going to be pulled back before it starts pulling back? No, I don't think so. With some sources, like if you're against a relational system, you could use table.row count, and it will actually just do a select top and get your count. Select count. So in that case, you could sort of check when you're in the editor. Usually, so with Power Query itself, when you connect to a data source, the editor is just going to bring back a sample of the data. So you're working with, default is 100 rows, and if you scroll down, it'll bring in the next set up to a maximum size. And it only actually pulls down all the data when you click apply. So yeah, until you click apply, you don't really know how much data is going to be pulled down. It'll give you progress, and you can cancel a query as it's running. But yeah.
And one of the things is you will, after you've done it the first time, you will continue to see the number of rows that are loaded. The next time you hit refresh, that can grow or shrink depending on your source, but you don't know really until you pull it down the first time.
Yeah. So also related to memory limitations. So Excel, we have two ways. In 2013, there's two ways to load the data. One's to the worksheet and one's to the data model. The worksheet itself has a limit of 1 million records. I don't recommend ever loading 1 million records to the Excel worksheet. It really bloats up your workbook. Anytime you're dealing with larger amounts of data, use the data model. Use Power Pivot. It compresses things down. The workbooks will be smaller sizes. They'll be more manageable. BI performs a lot better against Power Pivot as well. Okay. So that's it, I guess.
Yeah, we'll be up here for a bit longer if anyone has other questions. But otherwise, thanks for coming.
Yeah, thanks. Your settings. There's also this advanced editor button. So if I click on the advanced editor, I can see the full script of my query that I've just built up. So this is the full M language script. This you can write by hand. I find it's easier if you start with the UI, you start drilling around, and then go into the script and modify as needed. And so we'll talk about different scenarios and samples where you'd actually do that throughout the talk. Any questions offhand about Power Query? OK, let's jump over to the slides again. We'll start in on the language.
Great. So the Power Query formula language was informally known as M, or I guess is informally known as N. So you might hear it referred to as M. We'll actually probably even call it that a couple times. So design values, why did we build this language? The target audience is information workers and data analysts. So we're really focusing on the more advanced users in Excel, the people who are comfortable with using the Excel formula bar. And for these types of users, we wanted to make sure that the language was familiar and easy to remember. We want to make sure that it's a superset of what they can already do in Excel and similar to DAX, which is another language that is used in Excel. And we also want to make sure that while it's easy, that it also has the powerful capabilities for those users who really want to dig in and do more advanced features. So that's really what we're going to show today.
And so a common question we get is, we'll talk about this a bit later. We call this feature native database queries. So Power Query actually lets you type in a SQL statement rather than using Power Query to build up the query. You can type in the SQL statement and it just gets run directly. We'll tell you exactly why you shouldn't use this feature. It's not that it's useful in some scenarios, but as you see, as you're writing code, it's very limiting once you start using it. So keep that in mind. OK, so I can connect to a SQL Server database. It's going to show me my local SQL server, and let me just connect to one of these. And so I have some data here. maybe I'll remove a column, right? I can do some reordering, maybe remove some more stuff. I don't want this either. Great. And so as I do these transformations in Power Query, I did all those different steps. We log all those steps here. Right? You can actually see all the different applied steps that I just performed through the UI. And I can actually drill back through each step, and it changes. I can see the code as it goes from step to step and the different transformations that I'm actually doing. Each step has a formula behind it. Okay? This is the formula behind the step. You see it's actually very similar to Excel formulas. Okay? That's basically a function invocation that defines what the step is going to be done. By default, that formula bar is off. You need to go to the View menu here on the ribbon and enable the formula bar. And once you do it, remember Power Query itself, where it fits in. So we say it's part of the Power BI solution. It runs in Excel. I always say it's the starting point of the Power BI stack. It's the way to get data into the rest of your Power BI solutions. So Power Query is grabbing the data in. Power Pivot is building your models on top. You have Power View to visualize the data, and then Power Map to also visualize geospatial data, make movies, and things like that. OK, so quickly we'll switch over to Power Query, and I'll call out some of the key components you need to be aware of when you are wanting to use M. So Power Query has its own tab. Hopefully you guys, actually, so quick show of hands. Who here was in the session yesterday? Faisal and Miguel's session yesterday afternoon?
Great.
Great. OK. Who here has never seen Power Query before? Anybody? So a couple of people. Yeah, OK. So this is a 400-level session. Very brave of you to go to a 400-level session of a product you haven't seen. But hopefully it will be OK. So yeah, we have Power Query. It's a tab. It can connect to different data sources, a variety of different data sources here. You'll find that when you are using the M language, the Power Query formula language, you'll do a mix of using the UI and also writing actual code. OK, so here I can connect to a SQL Server database. I'll type in localhost. One thing I want to call out on this dialog right here, so here I'm connecting, and there's this SQL statement here. And we'll talk about yet another language. Why do I have to learn another language? I know SQL. I know DAX. Why do I have to learn M? And it is a very valid question. And so our answer is usually you don't necessarily need to know M. Power Query does a lot. You can do a lot in Power Query without ever having to touch the language. It's more of an advanced scenario thing. And the reason why it is another language is because it's meant for data transformation. Talking with customers initially, especially once we're very familiar with DAX, they kept saying, why isn't it just DAX? Just make it DAX. And once they start using M and seeing how the language flows, it starts to make sense. And now we have many M converts among the DAX community.
Great. So jumping right into the syntax. So syntax for simple queries in some of the other languages. So in SQL, you can see here that we typically select the columns and then choose the source that the columns are going to come from, and then you do your projection at the end. Then C# link, and in C#, you can see that we connect to the source, and then we do the projection, and then we select the columns at the end. So now comparing Power Query, which is going to do the same thing as the other two examples, you can see here we have a slightly different syntax. We have this let and this in, and in between we have a series of steps. And the order that we're doing in these steps, we are going to select the source, then we choose the columns, and then we choose how to sort. And
All set? Your mic on too?
test.
OK. Great. Let's get started. OK, welcome, everybody. My name is Matt Mason. I'm here with
Tessa Palmer.
And today we're here to talk about Power Query and the Power Query formula language.
So quick peek at the agenda. We're going to start with an overview of Power Query, why you would even use Power Query and this Power Query formula language. And then we're going to do an introduction right into the language. So we're going to talk about types, values, functions, and we're going to spend a lot of time on examples. So real-world examples where you're actually going to use this formula language to do a little bit more than what you can do just through the UI.
Yeah, and so underneath Power Query, there's a whole formula language, which is what we're focusing on today. And things to keep in mind is that we don't expect you to actually learn the whole language within this 1-hour session or 75-minute session. So we're basically going to point you in the right direction. It's just recently that I had to learn the whole language. So I'm going to point out some of the things that helped me learn. And Like we said, we'll post all the samples and examples afterwards. You guys can sort of follow along. The goal is to give you enough background on the language itself to make you dangerous. So quickly about